Okay, good morning. I hope you all have already come over the party last night. Yeah, so I'm going to talk. If you looked at the schedule, it would be called "Take the Next Storage Step." The storage did not fit into the slide, and I'm no real graphics guy, so I just took it away. No, it's also the reason because I'm adding a little bit more that's aside of the storage part to my presentation today. Maybe not. The other one, yeah. Yeah, maybe some words about our company. The sports enthusiasts amongst us may know Runtastic. We're, beautiful text. We're doing sports tracking. So if you go out for a run, you can track it with our app or with some gadgets that we have in our ecosystem, and you can upload it to our platform and then do some statistics or compare to other users. So we've been founded in 2009. We are located in a small town called Pasching in Austria. You may have not heard of it, only if you're a fan of Werder Bremen, because that was the only real football club that we ever won against in European level. We are part of Adidas Group since 2 months. Adidas may be known. We have 160 million app downloads and around 75 million registered users, and there's 140 employees working for us. So if you look at the 160 million app downloads and the 75 million registered users, that's quite a big challenge to provide a system that provides sufficient resources for all the services that we offer to our users. So if you have a look at our technologies overview, we have some databases, physical, and we have some infrastructure machines like NetApp storages and firewalls, and we have a Cassandra Cluster that's also physical. And then we have the OpenNebula virtual environment. When you started with OpenNebula, it was in 2013. We started very small, and we thought, we would have like the normal growth curve. We started with 8 nodes and some cores and some memory, and like now it's like 2 years later or 3 years later, we are at 2,800 cores in our virtual environment and 12 terabytes of memory. And so you can imagine that growing from like 8 small nodes to like 50 very big nodes now can be a challenge in many ways, especially if you look at the infrastructure around the whole thing, like network and storage and stuff like that, because it's very easy to add some servers to an environment. You simply need some racks and put it in there. But if the rest of the infrastructure doesn't grow with the system, that can be the challenge. So we have around, in our productive environment, it's around 400 different virtual machines with, that's only a part of the service software that we use. And we have a second OpenNebula environment for our office infrastructure. So why should we change anything on the storage level? So we have our NetApp storages at the moment. So it's the classic enterprise storage environment. But the problem is it simply doesn't grow, or you're not able to scale it in a way that you scale all the other technologies. You can't just simply add another node to the whole thing and then it's providing more performance or more space or whatever. So what we wanted to have is something that scales out on the storage level, that has a higher resilience against failures. I mean, our NetApp storage is redundant in redundant controllers and everything, but still it's one box. So if you need to do anything on that box, you need to take it down. then you can say, okay, I have a second box and a second data center or whatever, but still, it's always a huge impact on your infrastructure. So that was another reason we wanted to be able to do maintenance whenever we want to do it, not on special maintenance windows and stuff like that. Because if you have an infrastructure that provides services for people all around the world, it's getting more and more complicated to find windows where you can do something and not affecting a lot of people. And another reason was consolidation. If you look back on that slide here, that's just an idea. We have the Cassandra cluster here, and we use it as a simple key value store. So there was an idea, because if you look at that, the right part here, we have the classical problem of a company that grew very fast. We have like, I don't know, 40, 50 technologies that we have to maintain, and we are 4 people to do that. So 4 people to do the network layer, the hardware layer, the virtualization layer, the application layer, the operating system layer. And that can be quite challenging as well. So whenever we find possibilities to consolidate technologies, we want to take it. So since we use Cassandra as a key value store, would be another thing to, for example, go to Ceph for that. Yeah, so NetApp, it's good, it works, no problem with it, but it's a scale-up thing. So yeah, that's the way that we go already, and that we want to go a little bit more in future. So we started with our Office OpenNebulaCluster. It's actually a very small OpenNebulaCluster. It has like 6 or 7 nodes, worker nodes, and at the moment it doesn't have a NetApp, but it has like, you buy a case on eBay, and then you add some disks, and then you try to do B3FS RAID 10 on that, and then you find out after some month that B3FS doesn't recognize when a disk fails, and then you go to ZFS on Linux, and it works. But at some point you need to do something different. So we started with our Ceph cluster in here. We have 5 hosts and having journal SSDs, and it's 60 SATA disks in there, so we have around 20 terabyte replicated space on that cluster. And we have in preparation, we have the cluster for a productive environment. It's 20 hosts and 120 SAS OSDs with around the same size that the Office cluster is, but without the SSDs for journaling, at least for the start. The reason is simply because we use Cisco UCS servers, and if you want to buy SSDs for Cisco UCS servers, that can be, you can buy some houses for that. So that's the main reason that we start with the disks only. So that's the plan. That one is in production, that one is planned. Integration in OpenNebula with Ceph. Maybe that's the thing that you're most interested in. It's actually quite easy. That's the cool thing on it. You have to have a Ceph cluster. That can be challenging in some ways, but you create your client key rings and roll it out with your software configuration management to your OpenNebula nodes. You create some pools if you want to have more than that, and then you create your data stores using the pool or the several pools, and that's it more or less. If you use authentication on the Ceph level, you need to do that, and you need to do the libvirt configuration for that. But the integration in the OpenNebula cluster is something, I don't know, Gerhard, how long took it? Like 1 hour or something? Yeah. So that's very easy to do. That's very well documented. Just do it. Yeah, and then you can already create images and fire up machines. That's maybe one thing we have to add. In the first place, we wanted to just migrate our images that we have from the NFS data stores that we use to the Ceph data stores, and we skipped that plan after we did like 2 or 3 images because it took like a very long time. And the problem was more or less that our OpenNebula node where we did the migration simply didn't have enough disk space to do the temporary image copying thing. So you need to bear that in mind. If you have big images that you need to transfer, it's probably faster that you do it on another level. For example, creating a new image and doing an rsync or something like that. At least for us that was. We added then SSDs to the host so that it would be a little bit faster, but still. Yeah. So integration OpenNebula is not the problem, but we had some learnings, especially on Ceph. I guess some of you also have. There are some things. Ceph is hyped a lot at the moment. So for some people, it seems to be the magic, the holy grail for all the storage problems they have. If your all-flash NetApp storage doesn't provide enough performance, you get a small Ceph cluster and it does it. And no, that's the one thing. Ceph is not the answer to everything, at least from our point of view. And because there's some things you have to bear in mind. The one thing is you always have to use appropriate hardware. We did some performance tests on Ceph, and we used, in the first place, we used Cisco hardware that Cisco provided for the test because they were very interested in having a Ceph cluster running on Cisco hardware, and they provided us SSDs that were, yeah, I don't wanna name the producer, but the disks were not the fastest ones and not the best ones, and not the especially when it comes to throughput. So we had the tests, and using SSDs was slower than using normal SATA disks. So that was the one learning. It's not always faster that you use SSDs, also on Ceph. The other thing is, and that's something that we see now in our productive environment, you saw that we have like 20 nodes and like 120 disks in that cluster, and we have, we fired up everything, cluster is running, then we did some benchmarkings, and then we found out that with 120 disks, we did like, I think 500 megabyte throughput on the whole thing. So we thought, well, that's probably not nice if you bought like 120 SAS disks, having 500 megabyte per second throughput on a benchmark. So the main reason for the problem was that we were using, I don't know if you know the Cisco Nexus switches with the fabric extender line extenders. So the problem on that is because it's only line extenders, it doesn't have a switching logic. Every packet that you send into the switch is sent to the Nexus, and then sent from the Nexus back to the same switch because it was the next port that it would be intended to go to. So you have like a non-blocking Nexus 5K switch, but the problem is that your uplink from your fabric extender to your non-blocking switch is like, I don't know, 20 gigabit, and you have a backbone of 20 gigabit on your non-blocking switch. So there's some things you always have to bear in mind. We are aware of that. We now have a project where we change our network because it also hits us in some other technologies. And another thing that and that's the last point here on that slide, is really try to understand how Ceph works. Because if you don't understand how it works, especially from the crush, the whole crush part, crush algorithm, crush rule set and stuff, you can really fuck up your infrastructure. We read over the Ceph documentation over how the crush rule sets works, and yeah, cool. We are cool guys. Just write your rule set, put it in there. Oh well, the whole thing does. It's spreading across the nodes. And then we found out that actually every write went to 3 OSDs, but the OSDs always have been in the same host. So things like that, you really have to check if that really works. That's what I want to say, because we only found out that it did not work by taking down one of the nodes and having a cluster that did not react anymore. So you don't want to find that out if you're already in production. Yeah, and then that's also one of the reasons that I took out the storage from the title of my talk, because I have somewhat else around the Ceph and the storage topic. And the last time that I've been here, I looked at my slides, and we were talking about integrating LXC into OpenNebula, because for some, we also heard on the first day at the hacking session that there would be some advantages in using container virtualization additionally to KVM. And especially for us, we have an environment that's completely used only by our company and only by more or less the 4 guys that are doing the productive environment. And so we started with LXC. There is a project, I think it's from a Chinese telecommunications provider, but it was for OpenNebula 3 something, and so we would have to migrate it to OpenNebula 4, and we simply dropped it because it was a lot of effort to put into there, and especially LXC was not really ready to be used as a container virtualization that was clustered and spread over several nodes. So, but since a month, you may have heard of it, Ubuntu or Canonical worked on LXD, which is more or less LXC with some interface. So that when we read that, it was like our alarms were going. And I already had a look at how it works. It's a RESTful interface, so it should be very easy, fairly easy to integrate it into OpenNebula. Still, I'm going to wait a little bit until one of you did it and then try it. But that's one of the plans, especially because of the point number 3 on that slide here. Because until now we use OpenNebula like standard virtualization, like you would use VMware vSphere. So we have our virtual machines with persistent images, or mostly persistent images, and you always have to, which machines are running in there, and you know all of them, and it's friends of you and a family somehow. But if you start to change your way of using OpenNebula, for example, you let other users use the cluster and give them some machines that they can fire up and that they can kill and that whatever they want to do, like for example, that's developers in our case and QA testers. It's nice if you have a solution, a technology that where the machine fires up immediately, more or less. Because if you fire up a KVM machine, that can take some time, and then you have to do something with it. And if you use containers, it's quite fast. That's one of the reasons, and it also the resource overhead is at least a little bit lower, the footprint. Yeah, then something else, the network will be redesigned because we are limiting it completely. We were very happy when we started with the 10G network. We thought that we were the coolest guys in the world, but now we know that we need to do something else, or at least go to the next level, and that's the same thing that we do on a lot of technologies now. And the cool thing is, we can grow with it in OpenNebula. That's the really nice part of it. That's something that we found out. We started small, we added nodes, was no problem. We started small on storage level, we can have a scale-out storage, no problem. We can change the way we use the network. For example, we plan to use VXLAN in future, because we also limit our IP capacity more or less in our networks, the way we use it at the moment. And everything works with the integrations of OpenNebula, and you can easily adapt it to your needs. Exactly. Then there's another point. We want to start in our office environment with to simply give resources to our users. I already said it. It's developers that do our backend infrastructure. It's QA testers. And we have different environments from development over staging and pre-production. At the moment, we are all is managed by us, by the 4 guys that I mentioned before. That's a lot of work, and you can do it differently. I guess that's something that a lot of you already do because that's your main business. So that's something we want to start now. For that, we want to have the marketplace to be able to have, for example, for the different services that we have. I think we have around 20 different application services. One is off now. No. Yeah, and so we want to prepare all that images in the marketplace so that the developer. Another thing is we want to use the I think I just used that. Yeah. So, yeah, wonderful. So we want to use one flow for two reasons. The one reason is that's something that we already prepared. And that's the last point here on my slides. That's the pets versus cattle. I don't know if you've heard of that. That went around a little bit in the operations community. It's how the way you treat your services. At the moment, everything is a pet. It's family, it's friends. You know it. There's this server. I know it always has this problem. You know what you have to do. Monday when you come into office, you need to restart that, or you need to do that on it. And we want to get away from that. We already started with one or two of our services to treat it more like cattle. If the whole thing doesn't work, you kill it. Maybe you can sell it, but normally you buy a new one. You just fire up a new machine with the same service. So that's the change in mind. And yeah, more or less for OpenNebula, that means using non-persistent images instead of persistent images. I'm fairly easy on that one. So, and we want to go more into that direction. And that would also mean that we are able to use autoscaling, to use cloud bursting. That's all things that we are not really able to do at the moment. And yeah, so that's it from the what else part. So I'm already at the end of my talk. Any questions on whatever?
Thanks. Have you? What is your experience regarding about running database on top of Ceph? Yeah, especially Postgres, SQL, Oracle, MySQL.
Yeah. So you may remember that slide here. That's also something that you have to always think of. It's less a virtualization issue or an OpenNebula issue. It's more a storage issue, because you see here we have MySQL as a physical database. Because it's very big, very resource consuming, it wouldn't make any sense to put it on virtual environment, because you would more or less use the whole resources of one node for it, and still you would not be able to do it on a central storage. So we also run Cassandra in physical environment because we have like 64 nodes. It would not make sense to put that on virtual environment if you would use the resources of all of that nodes. But we use a lot of databases in the virtual environment. We use Redis as a queuing system. We use also MySQL for smaller applications like the web shop or whatever, or a blog. That's things that run completely in virtual environment. And that works. But if you have issues on that, it's all of the time it's storage issues. So it's that there's some virtual machine consuming a lot of IOPS at the moment and then affecting other virtual machines. So we had that question actually because we did a migration from MySQL as being the core database to MongoDB being the core database, also because of scale out versus scale up. So we needed to decide what to do with MongoDB. And first, if you ask the guys from MongoDB, they tell you never use any virtualization, it won't work, and do it on physical machines or on Amazon Cloud. I don't know why Amazon Cloud is better than virtualization, but it's a different story. So what we did on MongoDB was using it in OpenNebula, but using the device, the physical device data store, and giving SSDs that are in the host directly to the database. So there's one SSD and it's for one machine. So that's what we did actually. You can also do it with if you don't need the power of one single SSD, for example, for a database, you can have partitions or LVMs and put the logical volume to the machine. But you stick to the one node then. Any question?
Yeah, I have a question. Do you operate your Ceph cluster on IPv4 or IPv6? Because while you were talking about running out of IP spaces, IPv6 is quite hard to get to run out of. So.
No, I'm totally afraid of IPv6. I don't want to talk about it. It makes me cry. So no, we run it on IPv4. But the problem is more in application side because all our application servers are in the same subnet. So that's also historical, more or less, and that's something that we need to change for the future. And by that, it's more easy to go with a different solution than just a classic subnetting and having virtual IPs and then a firewall that does the routing in between.
So, have you tried to use or limiting the IOPs from OpenNebula side in the template in the?
That's actually a quite funny story. We tried it and it did not work, and then we found out the reason why it did not work is that every instance in our environment is run by one admin. So, yeah, and simply you would need to have different users running the machines to be able to limit it. So that's also the reason why we have that the whole topic of how we should use OpenNebula, because that's something that we want to start also to be able to do something like that. Because when we have developer machines, you all know what can happen if you give a machine to a user and he probably does not know what he's doing, or at least does not see what he's doing, and then you have a machine that consumes like IOPS and IOPS and IOPS because he does something in Redis and forgets to drop the database, and Redis is persisting every 5 seconds or something to disk, like some gigabyte of data, then you have a problem. So before we can do something like that, we need to do something like limiting IOPS. But on the other hand, that can be a problem if you have a service that maybe really needs the performance at that moment. So, yeah.
We are about to take the same sort of step, and I just wondered how much time purely on Ceph did you spend from reading the documentation until you had your first cluster that you were satisfied with?
Yeah, it was, to be honest, a lot more time than we wanted it to be. And it was simply because it sounds very easy and it sounds very logical if you read how the whole thing works. And in the end, in the real world, on your hardware, it can look different at least, you know. So we're a company, we just, if we have an idea, we just do it. And also if we don't know anything about it, we just start with it because there's always a way. That's more or less the mindset that we follow, and it works. But sometimes, and with Ceph we had that experience, it can take a lot more time. So we already knew that it could be a little bit difficult. So we started with a project with Cisco and our hardware provider in Austria to do like test setups and do first tests on that one, and then it can be different if you change only little parts. For example, if the network's a little bit different than in your tests, and so it took quite some time. So I don't know, was it some month, 3 months or something like that. So installing the whole thing and setting it up is the one thing that's easy as you can imagine, but tuning the whole thing and finding out where your bottlenecks are is another story.
Have you faced any disaster recovery event, and how with Ceph, right?
That was actually the real cool part, because we by accident did that a lot of times. You know, when you change your infrastructure while you do the testing, you will organize some disasters to learn from. The thing was, for example, we had while we did the performance testing, we had 1 or 2 virtual machines running on the Ceph cluster just to see what happens if you outperform the cluster and the machine is running. The machine was running. I mean, it was slow from time to time if there was a real problem, and also the one time where we had the wrong crush rule set and having all the replicas on one host, and the one host went down, we had a problem because the thing simply was not able to write and read anymore. But the cool thing was, at least in, I would say, nearly all of the cases, rebooting a host or whatever was enough to recover. So it just took some time. You always have to know that if you take down, or if the more hosts you take down in Ceph, the longer recovery takes, or the more hosts you take down, you may also have an interruption. But at least for us, it did not mean that we lost any data. But there is not, at the moment, we only use it in the office environment for, I don't know, 10 to 15 machines. So there's also not that much traffic on there at the moment.
Just to comment a bit, we actually took down our Ceph production cluster. We ran it full and had 150 VMs running or sitting still. Amongst those was Oracle databases and stuff like that. We redistributed some objects and made it running again, and every VM just resumed its IOPS capacity. So it's really nice.
So before we move on to the next talk, do you have any parting guidance, tips, or
Sorry?
Do you have any conclusions you want to share?
No.
Excellent. Okay. Thank you, Armin. Thank you.